Hi guys. So earlier I talked about the one-dimensional array of the Christmas cards game, which I'm sure is quite easy to understand. Yeah, but what about extending it to two dimensions? Yeah, actually the pretty much the same rules still apply, but there are some rules which are a little bit modified lah. Okay, so the Christmas cards games, the rules are all pretty much the same, except this time round you can imagine the cards being in a 2D array. Like for example, it has a length and it has a width. Okay, yeah, so this is how I'll draw it out. So you can imagine like there's one card here, one card here, one card here, and one card here. Yeah, for my example, I'm still using 4 cards. Okay, yeah, the 4 cards can also be arranged like this: one, two, three, 4. Okay, yeah, that's right. Yeah, but then the cards can also be in one horizontal line just like this, right? Yeah, so but then to determine like the exact positions of where the cards should be is a little bit difficult. So what I did was that I created an entire 4 by 4 array. So sorry, my drawing is quite bad. And a fun fact, I got F9 for art when I was in secondary 2. Okay, so the positions of the cards, right? It can be like at this spot, this spot, this spot, and here. These are the positions of the cards, and the surrounding squares over here which I have dotted, they are actually defined as like null spaces. Okay, so later on in my code in the example that you'll see, right, I have defined a green card, okay, green, to be a value of 1, and a red color card to be a value of 2. All the null cards, they are defined to be 0. So going back to this 2D array, right? Okay, you can imagine it like this. So let me just draw it out again. So if let's just say this is a red, if let's just say this is a red card, so this is a 2. If this card here is also red, then this is a 2. This card here, let's just say it is green, so it is a 1. And this card over here, if it's also green, then it becomes a 1. And all the surrounding cards are marked as 0. I've decided to use integers instead of Boolean variables because it is easier for the example. Okay, yeah. So this is how the Christmas cards game work. Yeah, the orientations are like randomized, and there's no like specific one which either player can start with. Yeah, once again, the objective of the game is that player 1, if player 1 is red, then he must make all the cards 2. This is to make sure that like he must make sure all the cards are red. So this can be represented by 2, 2, 2, 2. And if player 1 is red, then player 2 is green. And his objective is to make the cards all ones. 1, 1, 1, 1. Yeah. So once again, when you flip one card, like let's just say you flip this card, the adjacent cards also gets flipped. So if this guy over here is flipped, it becomes a 1. Oh, sorry. My bad. the rules, okay, these are the modified rules, okay? So when one card gets flipped, right, as long as the you're within like as long as the card adjacent to it is within like the surrounding 8 squares. So the surrounding 8 squares of this guy over here is 1, this guy, this guy, this guy, 1, 2, 3, 4, 5, 6, 7, 8. If there's a card at any of the 8 spots, right, those cards will get flipped as well. So in this case, right, this is a number 2. Number 2, okay, I will now draw a 3 by 3 grid because I want to show you what I mean. So number 2 will still be at the center. So the surrounding 8 squares are these squares over here. And as you can see from the zeros, they do not change because like they have no cards placed in that position. So it should look something like this. But the cards over here, right? Can you see the 2 above? This 2 over here and these 2 ones over here, they will get flipped. So this 2 over here becomes a 1. The 1 becomes a 2. And the 1 becomes a 2. And last but not least, itself also gets flipped. So this guy here will also be flipped. So from a 2, now he becomes a 1. Yeah, okay. Yeah, so this is pretty much how it works. Yeah, the same rules still apply. So imagine if it is player 2's turn. Sorry, I did not specify which color player 1 went beforehand, but okay, if let's just say player 1 goes as green from the start. So player 1 is green, right? He flipped number 2 and number 2 now becomes a number 1. So player 1 flipped a red card to a green card and the surrounding cards also gets flipped. So we can obviously tell that the winning move of player 2 is to flip this guy over here because because you know what I just mentioned. Sorry, yeah, actually this guy, yeah, I mentioned that when a card gets flipped, right, the cards in the surrounding 8 squares, right, sorry, if there are cards in any of the surrounding 8 squares, they will be flipped as well. But this is not an accurate depiction because this is just a 3 by 3 grid. The actual thing is a 4 by 4 grid. So let me just draw it out again such that you can visualize better. So okay, this is a 4 by 4 grid, right? The orientation still remains the same from right here. So but then the 2s and 1s, they flipped positions. Okay, so this is still a 0. The zeros still remain the same because there are no cards in those positions. So zeros, okay, zeros, except that now this guy here is a 2, this is a 2, and this is a 1, this is a 1. So the winning move for player 2 is to flip this guy over here. So if you notice right, for this position, above this number 1, right, there are no cards because this is the uppermost row. So you only look at the surrounding 5 positions. The 5 positions are over here: 1, 2, 3, 4, 5. As long as there is a card in any of these 5 positions, they'll be flipped, and itself also gets flipped. So when this guy flips, when player 2 flips this card over here, now this guy becomes a 2, and from a 1, right, because it's a 1 down, is 1 position directly down, so this guy also becomes a 2. Yeah, so now we can conclude that player 2 wins. Yay! Okay, so yeah, that's pretty much it. The only rule which I have modified is that if you have a card in the center, right, if there are no other cards beside them, you don't have to worry like this. But if let's just say like surrounding any of the surrounding eight squares of this center card also have cards, like if this is 1 and 1, these two cards will also be affected and hence they'll be flipped. So if this guy is flipped to a 1, if this guy is flipped to a 1, then these two guys over here will be flipped to 2s. So if I just erase this, they'll be flipped to 2s. Yeah, so the objective of the game is to make every card the same color. Yeah, so let me just run through my code with you. Okay, this is a little bit more complicated than my previous code because I've added in a hash map, which I might explain in a separate video. And also I'll be putting this code I'll be linking it in my description below. So I called it two dimensions. Okay, so once again, let me just explain from my main function. So empty position is a 0, then 1 is depicted. 1 is 1 describes a green card, 2 describes a red card. So once again, over here I have defined a 2D integer array consisting of zeros, ones, and twos. And and just like my previous code, I've also added in a scanner. This is to allow users to input. So what I did was I first called the getWinner function. So if we look all the way up here, this is the getWinner function. Eventually we will determine who the winner is, but we just need to define some rules first. So if let's just say like the length is 2 that means it's like impossible to tell who wins, right? Like previously in my previous video I mentioned that if red gets flipped, then like green gets flipped, or if green gets flipped then like red gets flipped. So it's like really impossible to tell because like the maximum array is 2 by 2 array, so there are only like 4 possible positions and they'll definitely be touching each other, so one will affect the other. But like in this case, right, even if you have 3 cards, right? Okay, let me just like show you the example of 3 cards. So 3 cards can be like, you can have a you can have 3 cards is defined by a 3 by 3 array. Yeah, in this case, right, I just assume that the dimensions are the same, like the length and the width. This length over here and the width, right, are the same. So if there are 3 cards, I define them by a 3 by 3 array, and if there are 4 cards like the one above this thing over here, I define it using a 4 by 4 array. So only 4 cards are filled and the rest are all empty spaces. But for a 3 by 3 array, right, there are only 3 cards filled and the rest are all empty spaces. So it is possible to tell who is the winner for a 3 by 3 array. Yeah, so let's just say like someone just like, I don't know, cock up and arranges the card in this way. We have a red card, and a green card. And if player 1 chooses red, the winning move for player 1 is to flip this card, and now it becomes 1-1-1. So it becomes, sorry, by my drawing, it becomes 1 1 1. This card is not affected because it is not amongst the surrounding 5 squares, and it is 5 and not 8 because there are no cards above this guy right here. So 1-1-1 means player 1 automatically wins the game. So 3 cards or above is possible. But 2 cards and below is not possible, so I return them. Okay. Sorry, yeah, I return it out of the function. Okay, so once again we ask player 1 to choose a color, so choose color. Sorry, let me just go back. Okay, player 1 choose color. Is this thing over here is pretty self-explanatory, and it's actually very similar to what I've written in my previous code. Okay, player 1 chooses color, blah blah blah. Sorry, just give me a moment. Okay, so determining the number of turns. So if it's player one's turn, then if it's an odd number of turns, like turn 1, turn 3, turn 5, turn 7, then it's player one's turn. But if it's an even turn, if this turn is like 2, 4, 6, 8, or 10, then it is player two's turn. And I have actually defined it right over here in the get current player. So when this is an odd number, I return player 1, and if it's an even, I return player 2. It's defined by ternary operator. Yeah. So but the only difference is that right now I have created a hash map, and once again, if I have the chance, I'll explain what a hash map is in a separate video. But basically you can think of it as a Python dictionary. So you have a key value pair. So in this case, right, when you have a hash map, right, actually you don't need to specify like the data types of the key value pairs, but it is good to specify because that's like good habit. Yeah, so there will be an integer, and this m which I've created is a new hash map which consists of two key value pairs in which both are integer. But actually let me just show you a fun fact is that I actually experimented this with VS Code. But even if you don't have this, right, even if you don't have this this entire code still performs the same. Yeah, it doesn't really make a difference at all. Okay, let me just go back. Yeah, so integer. Okay. Oh, and one more thing you have to take note, which I'll be explaining to you shortly. If you don't have this part over here, it is okay. But if you don't have this, that's where there's a problem. Because I tried doing this, right, it is a problem, and you actually would need to specify like you actually would need to like specify the data type like somewhere else in the code later on. Yeah, but let me just like put this back first. Okay, yeah, so right now what I'm doing was that I told you about the 4x4 array, right? I determined the array's position. Okay, so this 4x4 array over here, right, this thing over here, okay, is given by like 1, 2, 3, 4. These are the numbers, then all the way until 16. Yeah, this is how it works. So for 4x4 array, I used a nested for loop. Okay, so initially it is 0. So every time I pass by one square, I first increment it by 1. Okay, and if I come across a square in which it is either a green card or a red card, what I did was that I actually inserted a key value pair into this hash map. So to do this, right, I use this method m.put. Yeah, it's a method which I'll explain in a separate video lah. Yeah, so plus count. Okay, so like plus count, this count is actually to determine the card number. So this is actually a pre-increment function. So what happens, right, is that step 1 is that count will increment to become 1 first. So now count takes the value of 1, and 1 is linked to the array position. In this case, it is 2. Do you know why it's 2? Because over here at position 2, right, at position 2 over here, this value is 1. So you can imagine this thing here, right, as a green card. Yeah, this is a green card. So the key of 1 is associated with the value of 2. So likewise, right, if you continue by this logic, I increment count one more time, so it becomes 2. So 2 is associated with 6, and 3 will be associated with 10, and 4 is associated with 11. Yeah. So I created a hash map because it is easier to determine like the row and the column of the array lah. So once again, this sorry, ignore whatever I just said. So there's a possibility that at the very start of the game, all might be red cards or all might be green cards, and in this case you don't need to play already. I mean, obviously there's a winner, right? So what I did is I determined the winning color. This winning color, the purpose of it is to determine whether there is a mix of red cards and green cards, whether there are only red cards in which the player who chooses the red card wins the game, or there are only green cards in which the player who chose the green cards wins the game. So this is represented by getColor. It returns 3 possible values. Okay, so let me just show you up here. Okay, so this is the getColor method. Okay, so I actually created a temporary array. Yeah, actually you can use this method. It's quite useful to keep track of the 1s and 2s. I do not care about the 0s because they are empty positions. I only care about whether there's a card in that position or not. Okay, so this is the nested for loop right here. So nested for loop, right? So if let's just say at that position, right, the value equals to 1, right? So number 0, which is this thing over here, it will increment by 1, and if that position contains a red card which is represented by a 2, this value over here, numbers at index 1, which is this thing here, increments by 1. So once again, right, the numbers, right, I actually have 2 index positions. The first index is to keep track of the number of green cards. The second is to keep track of the number of red cards. So this code tells me, right, that if numbers 0, which is this index here, if it is not equals to 0, and numbers 1, which is this position over here, if it is equals to 0, then I return 1. This means that this is not equals to 0 means all of the cards are green and there are no red cards. So I return 1 to show that the green player is the winner. So if number 0 is at index 0 is equals to 0, that means if this is 0 and numbers 1 is not equals to 0, so if this is not equals to 0 but this is equals to 0, then I return 2 to show that the red player is the winner. But if none of these two cases are true, that means if there is a mix of both red and green cards, what I did was I returned -1. Because if you have a mix of red and green cards at any point of the game continues. And this actually is represented by a while loop over here. So as long as winning color outputs -1, the game continues. So string current player get current player's turn. So this is just to determine, it's just to like output which player is it. So I talked about like this get current player position. If it's an odd numbered turn, it is player 1's turn, and if it's even number, then it's player 2's turn. So this function over here, okay, is to get the user's input. And once again, of course, like you only can input like card 1, card 2, card 3, or card 4, because like in my example I only use like 4 cards. But if let's just say there are 10 cards, then you can only input numbers ranging from 1 to 10, both are inclusive. Yeah, so but if you enter a number which is out of bounds, right, then it prompts the user to enter a valid card. I mean like if there are 4 cards, how can it be you entering like, I don't know, -1 or like 8, right? It's not possible. So if he enters an invalid card, once again, if the if statement is executed, this will not be executed. Then once again, this winning color, of course nothing changes, so the while loop still goes back lah. But okay, this is the interesting part. Now the user enters a valid card number. It can be 1, 2, 3, or 4. Yeah. So now I'll determine the position of the card based on the key. So remember the hash map that I was walking you through, okay? The hash map, right? The hash map is right here. So I told you earlier that 1 is associated, in my example, 1 is associated with 2. This is what 1 is associated with. And 2 is associated with 6. And 3 is associated with 10. 4 is associated with 11. Let me just draw out for you. Yeah, so sorry. So okay, so 2, 6, 10, 11. So 1 is associated with 2 because this represents a card. 2 is associated with 6. 3 is associated with 10. And 4 is associated with 11. So 1, 2, 3, 4, I define them to be the keys. And 2, 6, 10, 11, I define them to be the values. Yeah, so what I did right was that I first get the coordinate. So you can call this m.getCard method to get the value of the key. So if let's just say like the guy enters if the guy enters in the input, right, 3, so 3, right, so 3 will be substituted into this card variable. So m.get3, the key is 3 and the value is 10. So this coordinate here will be 10. And to determine the row number, right, remember in a 2 by 2 array, right, arrays start from index 0. So this is row 0, row 1, row 2, row 3, column 0, column 1, column 2, column 3. So if I want to determine where 10 lies at, right, can you see 10 is over here? So the row is actually row 2 because it's row 0, row 1, row 2. So it's row equals to 2, and it's actually at the first column. This is column 0, column 1, column 2, column 3. So column equals to 1. But how did I get this? So okay, so actually to get the row number, right, I actually just use 10 to divide by 4, and I define it to be an integer because like when this is an integer divided by integer, right, it rounds down to the nearest whole number, so it is 2 in this case. And as for column, right, you can actually use 10 modulo 4. Initially you get a value of 2, right, but then like this is column 1 over here, so you still need to minus 1 also. 2 minus 1 equals to 1. let's just say like I want to get the position at 5. At 5, right? Okay, but it's misleading because there's no cut over here. At 5, right, the row, right, you can get it by taking 5 divided by 4. If you have an integer division, it rounds down to the nearest whole number is 1. And the column number is, you can use 5 modulo 4. You'll get 1 at first, but you still need to minus off 1 because you're at column 0. Yeah, because like for arrays, everything starts at index 0. So this is the row number, this is the column number. So this was what I did. For row coordinate, it's just coordinate over length, and for column coordinate, I got the remainder and I minus 1 off. Yeah. Oh, and actually for this coordinate, right, I mentioned earlier about this thing here. If you do not have any, like, if you do not specify anything, let me just remove this thing over here. And if you don't have this thing over here, you actually will need to specify, you actually need to typecast this to become an integer. Because do you know why? m.getCut over here, it does not return an integer data type if you do not specify the types of data which was shown over here, which I have just deleted. So if I do not specify, right, it returns an object data type, which is why I'll need to typecast. But I don't want to make things confusing for you, so I'll just go back to this. So yeah, I think everything is back to normal. So I talked about the row coordinate, the column coordinate, and I told you about the surrounding 8 squares, and also like need to tackle edge cases. So modify array, right, what this array does is that it changes any 1 values to 2, or it changes 2 values to 1. So modify array, let me just show you up here. Yeah, it's right here. So the surrounding 8 squares, right, you consider like the center position, right, then the surrounding 8 squares is like the row above it, so it is from -1, the row in itself, which is 0, and the row below it, which is 1. So that's, yeah, it's less than 2 because like this thing iterates through -1, 0, 1, and -1, 0, 1 refers to one row above the row itself and one row below. Likewise for column, column equals to -1. -1 is one row to the left of it. Then c equals to 0 is the column itself, and then like c plus plus c equals to 1 is the column to the right of it. It does not go to 2, it does not go like two columns beyond. So the edge cases is to make sure the index is not out of bounds. So like let's just say I talked to you about like the topmost row, right? If let's just say this row coordinate I got a 0, the 0th row is actually the topmost row plus r, right? Plus r, like in, if let's just say like r equals to -1, right? So this thing here is -1. If it's -1, right, it will continue. Continue means, right, it skips everything else and proceeds on to the next iteration. Another possibility is if row coordinate, if let's just say the bottommost row is 3. 3 plus r, 3 plus r, right, it gives you 4. And column 4, sorry, row 4 in this case is out of bounds because there are only 4 rows, and the last row is row 3. There's no row 4 because, you know, for arrays, once again, indexes start at 0. So if it's greater than length -1, which is 3, right, then it continue. Continue means, right, in this case, continue means like all of this will not be executed and it just proceeds on to the next iteration. Because like, you know, if you have if else statements, right, only one of these 4 here will be executed. So if it continues, right, if it continues, that means it just goes on to the next iteration without changing any values. This is to make sure that I'm not accessing like a indexes out of bounds. So the same logic can also apply for columns lah. I'm not explaining it because the same logic is for the rows. But if you have any questions, I will just like reply to them in the YouTube comment section. Yeah. But else if right, if let's just say the values at that specified row or and that specified row and that specified column, if it is a green card, what I did was that I actually flipped them to a red card. Or if let's just say this is a red card, I flip it to a green card. Yeah, so this thing here actually gives the specified position, like the row coordinate. This is the center position, right? This is plus r, that means it can be one row above, below, or itself. And column coordinate plus c can be -1, which is to the left, 0, which is itself, or 1, which is to the right of it. Yeah, so all of this okay are pretty straightforward. Yeah, so this game will keep on playing, right? Okay, and the turn will increase, like if it's player 1's turn, then becomes player 2, but if it's player 2's turn, becomes player 1. But this is only the case, right, when the guy enters a valid input, because if it's invalid, the if statement will be executed instead of the else statement. Yeah, so at the end of everything, right, we'll check what the winning color is, like whether they're all reds or all greens. The game still proceeds on when there are a mix of red and greens, because I mentioned over here, while while winning color equals to -1, that means if there's a mixture of both, right? If there's a mixture of both, then the game will still continue and the while loop will keep on running. But if it's either 1 or 2, right, then it stops. So the last step is to print winner. So what print winner does is to determine what player 1's color is. Remember, player 1 has to choose between red or green, and the winning color. So if let's just say this is 1 and this is 1, the winning color is green. If they are the same, player 1 wins. But if player 1 chose red, if it's 2, and the winning color, right, is 2, then player 1 still wins because 2 equals to 2. But if this is 1, player 1 chose green and the winning color is red, player 2 wins, and vice versa. So print get winner. Wait, no, sorry. Print winner is right here, yeah. So once again, if they're the same, then player 1 wins and you return. So this will not be executed. This statement will not be executed after you return, because return is always the final step of the function. But if this is not the case, right, then instead player 2 wins. Yeah. So actually that's about it for my code, and I'm actually glad that I could do this in under 2 hours. Woohoo! But yeah, anyway, thanks so much for watching, and I hope you subscribe. Bye!